Standard Terminal Automation Replacement System, or STARS, is part of the FAA Terminal Automation Modernization and Replacement Program, otherwise known as TAMR, to replace the old analog systems. STARS is a fully digital system capable of tracking all aircraft within the terminal airspace. Before the initial takeoff, ERAM at the local ARTC sends the approved flight plan to STARS located at the local tower TRACON. When the aircraft takes off, the handoff information is immediately sent from the tower to the TRACON. This is done verbally and electronically. STARS receives 3 surveillance inputs from the following: one from terminal radar, another from en route radar, and it also receives ADS-B data from the SBS station. SBS is the Surveillance Broadcast Services, which is the station that sends out the ADS-B position report to STARS. STARS interfaces with several systems: long-range radar, short-range radar, interfacility data transfer, wide area multilateration, also known as WAM, and ADS-B. Each of these systems is connected to the STARS local area network through the Application Interface Gateway, or AIG. Along with the AIG, the STARS internal network has several systems connected: Communication Gateway, Terminal Control Workstation, Radar Data Processor, and Continuous Data Recorder. AIG is the router that connects the external systems such as radar, WAM, and ADS-B to the STARS network. Through the AIG interface, STARS can receive and deliver surveillance and flight data to and from these external systems. The Communication Gateway processes surveillance data from the AIG and provides the data to the Radar Data Processor, or RDP. The coordinate conversion is responsible for mapping the flight plan to the target on the STARS display, while target information is filtered to match the target with the corresponding flight plan. The Terminal Control Workstation provides situational awareness and computer-human interface to the STARS automation for the controller. This is where terminal air traffic data is displayed, and it's where the controller tracks aircraft and provides instructions to the pilots in terminal airspace. The RDP receives and processes radar and flight data to produce the aircraft data block and weather information along with safety functions. The raw radar data is accepted and processed into track data for the Terminal Control Workstation and Tower Control Workstation. The RDP also associates the flight plan with the target on display, handles weather information, and provides input for the safety functions. The Continuous Data Recorder allows playback of the display target, weather, maps, controller actions, and system messages. Air traffic data is continuously recorded for playback or printout purposes. The AIG is the interface for the SWIM Terminal Data Distribution System. It is within SWIM where STARS publishes and shares its information. The Tower Display Workstation is located in the tower and is similar to the terminal display workstation in that it displays the aircraft data block and weather information to the tower controller. When the raw radar data is accepted by the RDP and processed into track data, it is sent to the TCWs and TDWs, along with flight plan information, weather information, and inputs for the safety functions. The RDP produces these two symbols on the TCW display. The primary radar target symbol represents the aircraft's current location and speed. The beacon target symbol is the information that tells the controller about the actual aircraft, such as flight information. The history trails show where the aircraft has been and where it's coming from to show the progression of the aircraft's path. The predicted track line shows the future trajectory of where the aircraft is heading. The controller uses the sector boundaries to identify the area he is responsible for controlling. With multiple surveillance inputs tracking the same target, STARS is able to have a faster and more accurate update rate. When the target crosses a sector boundary, the terminal controller performs an electronic handoff of the aircraft to the en route controller at the local ARTC via interfacility data transfer. Thus, the aircraft is successfully transferred from the terminal airspace to the en route airspace.